Testing, testing, testing. Am I good here? Cool. It is a very saturated. Community members, member of last year. Oh no, lag. And the high-level way to think about MCP is you can think about it like the USB-C port for AI agents. So before we had USB-C on laptops ubiquitously, you had different connectors for networking, different connectors for random peripherals, and different connectors for display. But now, even if the dongle looks a little bit goofy, you can get a USB-C connector for pretty much everything now. And so what this looks like in practice is we'll have some chat interface or agent software, and then we'll have external services or tools that we'll want to have access to. And then you'll prompt the tool to say something like, tell me about the current firing alerts, or tell me about this metric. It'll do some thinking. It'll reach out to your metric solution, and then give you a response based on that tool. But how does that connection work? So the chat software is going to be made up of a couple of different parts. The first one is going to be an LLM or large language model. So an LLM is a form of artificial intelligence that gets fed a whole bunch of text and then trains on that text and then learns to predict based on its training data and any other context it has what the next response or what the next token in the response should be. So that's how the LLM works. But then how do we get the LLM to communicate to all those external services? Before MCP, it was an M times N problem where every different model you were interacting with and every different tool had their own connection. So the complexity you had to deal with was the product of the number of external integrations you wanted to have times the number of models you wanted to integrate with, which could be extremely challenging because even if you just support we'll just say 5 different models from different vendors and 2 tools, that's 10 different combinations you would have to support, and that problem gets out of control pretty quick. So what we did was we made a standard for interacting with external tools called MCP. So now you would just have an MCP server that would connect to each individual source, and then the chat application would just be able to interact with that over a standard protocol. So the MCP client would live inside of the chat app or whatever agent you're using and then speak to the MCP servers in order to access the external tools. And what an MCP server is it's a program that provides tools, resources, and template prompts to a chat application. So tools would be things like asking about metrics in a database, running commands, or accessing any API. You could also give it resources. So a lot of models will get trained, and if you ask when were you trained, you'll notice it'll be like a year in the past. And so if you're working on a solution that's changing rather quickly, you would need to feed it documentation or more up-to-date resources for your solution, and that's what the Victoria Metrics MCP does. It can give your AI agent access to up-to-date documentation. And then for helping to get started, you could also provide it prompts and templates so that way it's easier to get started with using. And because there's so many different MCP servers, or because MCP is so popular right now, there's a whole bunch of different ways where if you just have an open API spec, you can wrap that as an MCP server pretty quickly. So that's how the server side works, and then the client lives inside of the chat application, and then it will communicate with the LLM to get a response. And the way that communication works is that the query will be ingested into the application, and then it will communicate with the LLM to say, hey, here's the prompt. Do you have any tools that you think would be helpful for this? The LLM responds yes. It will tell the MCP client to go reach out to those MCP servers, execute a tool call, and then that response is structured in a way that the LLM can understand it and add it to its context and augment the response. So that combination of the MCP client and LLM are going to be the main building blocks of the agent, and they can be used for autonomous software development, or you could have it complete tools and tasks on themselves. And something that's becoming more common and was mentioned in the last talk was that AI agents don't live in a isolated vacuum anymore. Agents are constantly working together to go through flows. The most common flow being you would have one agent writing a test and then another agent validating that test, and if it fails, it will send the output and what went wrong to the previous agent, and that loop will continue until the test succeeds. Sorry about that. So a bit more specific now, we're going to talk about the Victoria Metrics MCP server. You can find the GitHub repo at the QR code on screen, and it is permissively licensed, and it can be accessed a ton of different ways. So you can grab it from the GitHub container registry. If you have the Go toolchain installed on your machine, you can grab it with GoGet. You can build it from source. Or we also have GitHub releases where you can grab the binaries, and that's how I choose to consume it. It was very straightforward to just write an Ansible playbook that reaches out, grabs the metrics logs, and traces MCPs and put them in my path. And if you're not using Victoria Metrics, there's a whole bunch of different MCP clients, and I'm pretty sure whatever observability tools you will be using have their own MCP servers. And then as far as MCP clients goes, there's a wide variety of clients that you can use with your MCP server. So if you're using VS Code or Cursor or the JetBrains IDEs, you can have it help you write code. I had a really good experience with the Z editor and GPT OSS, and there's also terminal tools like Warp, which try to wrap your command line experience and turn it into more of a AI agentic focused tool too. So the easiest way to get this set up in your client is going to be standard I/O, and what you will need to do is specify a name for the MCP server, the command you want to run, so like Docker run or the path to the binary, any arguments you need to apply for configuration, and then environments for things like secrets, or if you're using a self-hosted tool, you'll need to specify the URL. And then what this will look like inside of most tools is either it'll be a JSON file that looks like this, or it'll be inside of the GUI of your application, which renders down to a JSON file like this. And you can see whether you're using Claude, VS Code, Cursor, it's all pretty much the same. It's just you need to change like 1 or 2 lines of JSON and tab something over, and that was my experience playing with like 5 or 10 different MCP clients. And then once you configure the MCP tool inside of your client, you'll be able to either see in a list of available tools that you have, or if you're using something like Goose, you'll have to go inside of the settings, which I can show in the demo. And then if you need the list of configuration options, it's right in the README of the Victoria Metrics MCP or available at the QR code. And so there's 2 primary, along with standard I/O, which is going to have lower latency and have better security implications because it's just interacting over standard input and output on your shell. You can use HTTP. It will have higher latency and your threat surface is increased because now instead of just having to have local access to your machine, you have all the security fun of HTTP. There is something called SSE, but it's mostly deprecated, so you should pick between standard I/O and HTTP. And the primary time you would want to use the HTTP MCP transfer would be for things like a multi-user web browser experience where you can't feed it binaries to run or Docker or npx commands to run on behalf of you. And inside of the Victoria Metrics MCP, these are all the features you can have. So you can list what tenants are available in the system. If you're using the cluster version, you can get information about a specific metric or what label values are tied to a metric. You could ask it about alerts. So rather than having to go through like the VMUI page or Grafana where you have all hundreds of your alerts and you have to start searching and you kind of already know what you have to look for, you can ask it what alerts are firing in the environment and narrow it down from there, and it's much easier. You can also see what queries are currently running and which queries get run more frequently. You can construct logs, metrics, and trace queries just using plain English. So if you're not familiar with PromQL or you have users that don't want to learn PromQL or LogsQL, you can just ask it very simple questions like, tell me the request that had the highest latency over the last 24 hours. You could also ask it for statistics about like how often metric names are being used and what are the highest cardinality metrics in your environment. So that way, if you're trying to lower your observability costs, you can actually just ask an AI, hey, what are the highest cardinality metrics? Are any of these unused? And it will help you remove things, start you on your journey of removing things. And you could also use it to help you deal with retention filters and labels as well. And if you notice, most of those abstractions are, or most of those tools are just wrapping what's available in VMUI, but again, you get to interact with it in plain English rather than have to learn a tool or have to figure out how to expose this tool to your users. So it is demo time now. So this is Goose. This is the, do I need to zoom in anymore? Or is this good for everyone? Perfect. So this is Goose. We're going to try a live demo, but thankfully I have some pre-canned demos as well. So let's say I want to just see what alerts are firing in my environment. I just need to go and ask what alerts are firing right now. And then immediately I get developer. So we get to do live debugging now. So here's where you would go into settings for extensions. And you would be able to see I just had to set the bearer token for getting set up with Victoria Metrics. I think it might be a networking issue. Let's try that again. There we go. Live demos are fun. Thankfully, I do have chat history I could use. So here we can see, oh, come on. See y'all. So here I can check to see what alerts are firing inside of Victoria Metrics right now. It will run the tool call here, and something that's really nice is that we can actually see the output of the tool call. One of the things that delayed my adoption of AI was it would just hallucinate and make stuff up, but it wouldn't cite its sources. So if it did output something suspicious, I can now validate what happened, so I could actually see the JSON response here. Or if you're just doing like a normal chat workflow, you're allowed to have it see what links it researched on the internet. So here we can see we have an empty alerting and recording rule found, which is something I should look into later. I'm mostly focused on and that before, I get a little bit of a summary, and I could also see
Yeah. Hi, everyone. Thank you so much for joining in after lunch. This is track 2, and we would be starting with the first speaker post-lunch. I'd like to call upon Esteban, who will be sharing his insights on building trust in every artifacts with SBON. So Esteban, stage is yours.
Hello, everyone. How's everyone doing? Was lunch okay? Yeah? Hope that you don't get to fall asleep during my talk after lunch. So yeah, like the slide says, my name is Esteban Garcia. I'm a SBOMs and can you actually use the SBOMs for something useful and not just have a JSON document lying around somewhere. So what is an SBOM? If you don't know what an SBOM is sort of like a list of ingredients that make up your software, right? And it tells you everything. If you have container images, for example, it tells you everything that composes that container image, not only the software that you're deploying as part of that container image, but also any other OS packages that are inside of that, including licensing, versions, and even dependencies between each other. And basically, it all reduces to try to answer this question within your organization. By having an SBOM, you can actually answer, are we running any software with, I don't know, a non-permissive license in our enterprise? Or are we running any software that has this particular vulnerability in this component that has just released 2 days ago? This is basically what you want out of an SBOM, be able to answer this question. And there are other benefits. Chain because it has that complete inventory list of everything that is being deployed as part of your container image or software. Your users can actually see what you are deploying as part of that. And this third part, I think, is one of the most interesting parts from a regulatory standard. It allows you to actually help you meet regulatory standards if there are any in your company. There are 2 formats being used in SBOMs right now. I'm pretty sure that in the future we'll see more of them, but right now you either going to be using SPDX or CycloneDX. SPDX it's the first format that started all of this, and it has a more of like a licensing angle. If you are more interested in knowing licensing of your software, especially around regulatory standards, Order 14028 that was mandated in 2021 by the US government is what basically started driving SBOMs massively. Basically because it said that if you are a vendor and you want to sell software to the federal government of the United States of America, then you must have SBOMs in all of the software. Licensing, components, and versions is not only just the name. And finally, EU Cyber Resiliency Act, it's quite a mouthful. If you are in the EU, this is not something that's only US-based. The EU has something very similar, which is that, the EU CRA. And it's then again, a set of security standards that we follow in the EU for the same thing. So this is why you want an SBOM in your company, right? But it goes beyond just being able to sell software to a public government or entity. Thanks to this and to the executive order that started everything, private companies are following the same, and the commercial world is following this same set of standards. So how does an SBOM look like? Usually people don't actually get to see the JSON behind scenes. They just generate the SBOM and then they run the SBOM through different pieces of open source software. But this is how it roughly looks like. This is a very small example of an SBOM. It usually takes the form of an XML document or a JSON document. And the first thing that you will see is the format that the SBOM is using. In this case, CycloneDX specification version 1.5. The next part is metadata about the SBOM, specifically provenance, freshness, what tooling was used to generate the SBOM document, and also what is the SBOM describing. So if in this case, you will see that it says type container, has a name and a version. So that means that this SBOM is describing a container image of the name my app and version 123. And the next part is the meaty part, right? That list of ingredients, which is actually what you want out of the SBOM. Around integrity, now this particular example doesn't have it because it's completely optional, but you might see cryptographic hashes as part of those components, and you can use those hashes to actually determine if there has been any component that has been tampered with since this SBOM was created until that container image was deployed on your infrastructure. And it also contains, as you see, licensing, which is something that you can use to actually know, is my company running any software with non-permissive licensing, like GPL-free, for example? No one wants to use that. You can get that information out of the SBOM. Okay, so now I've established this sort of like roadmap to walk through you around how you can actually create a CI/CD workflow in your company to go through SBOM generation all the way to actually using the SBOM at the end as part of the CD pipeline, sorry. And we're going to go through all of these four as part of this presentation, starting with SBOM generation. Now, SBOM generation, the best practice around this is that it should be integrated directly into your CI pipeline. If you are building a container image or if you are building software, you want to generate that SBOM as well as part of your CI pipeline. You don't want to do it as an afterthought. If there is any time gap in between the moment that you built your software or container image and the moment that you created that SBOM, it leads into question if that SBOM is valid or not, and if the software that was deployed is actually meeting that SBOM compliance. And this is a very brief example.
Have somewhere. Super easy. Today's Saturday, right? So Monday at the Observability Day co-located event, they're going to launch 4.2. So this is a little bit dated, but it's the most recent information and includes a link at the bottom there where you can go see Eduardo, who is the founding creator of this. We'll walk you through some of the new stuff. One of the really neat things is the JSON parsing got 2.5 times faster. So this stuff was already so fast. I mean, you're not even going to be able to see it happening. You know, it's just so quick. They added GPU metrics plugin, which is new. Some stuff around Prometheus to text files. I'm also the docs maintainer, so I got to run around after he released all this and made sure that it was all properly documented. A bunch of stuff added to these new plugins. They've all been rewritten in the docs also, so it's all there. And some security stuff and some observability metrics. Support and just host as an open source kind of available tool workload at the basic level. I had the whole workshop set around using the Ghost CMS. And it turns out in September, they quietly published on the Bitnami website that they were going to pull all this stuff and make secure ones only. So I go looking around for the secure one and it doesn't exist. So basically the Ghost thing's gone. I'm like, oh great, I promised to come here and tell you guys about how to do this with a real workload. So I had to sit down, I had to rewrite the article, I had to rewrite the demo, I had to rewrite the workshop, all this last week. And so that's what you're going to get to see here. So this used to be a CMS, and I'm going to go back and revisit this, but in the interest of time and the amount of work I had to do this week, I just did a very simple log generator which I think really doesn't matter for the beginner level and looking at what we're trying to achieve. It's not about what the workload is that you are actually getting a workload that you can capture, right? So we have a cluster that we spin up. I'll show you that in a second. We have the log generator generating workloads on top of all the other crap you're getting out of a Kubernetes cluster, right? And it's a lot. It's a lot, as you will see. Pretty much everything in the Kubernetes clusters, if you're aware of that or not, can be found in var log containers. So basically, each one of your containers has a log file in there. It's kind of a pain in the butt to go in there and do kube control and go look at each container, find its name, get its pod name, and then go look at its log. This is like multiple commands and kind of painful, right? Or maybe you use K9S, you know that? Yeah, it's fun to look at it very visually, but it's not exactly what you want for a developer, right? You're trying to get a little bit more fine-grained control. So we're going to put a telemetry pipeline in there, Fluentbit. We're going to deploy that with a Helm chart. That's going to take over that whole directory of logs, and it's going to consolidate them in one container for you. It's going to show you it in the output. We're going to configure it to do that. We're going to use something, anybody here familiar with tail command on Linux? Anybody not familiar? That's probably a better question. It'd be a little painful if it wasn't. So basically what you're using is a tail plugin, which just, you point it at a file, and I'll show you the configuration. And what it does is it tails that file. Now, normally that'd be great, but we spin up the cluster, and the last thing we do is deploy the Fluentbit container pod. It starts picking up the logs, it tails stuff, and what's it catching is only the stuff that just happened. So my workload's already been deployed, it's done its logs. I want it to go back from the beginning of that log container, so that's one of the settings we turn on in the plugin to say go back and get everything in every single log, and then we're going to start outputting it. So let's try and do that and see what happens. Sorry. Here. So I'm going to show you this is from the actual workshop demo that I rewrote and also is available to you if you're doing it. I'm a big fan of saving the history of ASCII art. So you'll always find ASCII art in all the install stuff here that I do. Basically going to hit an init script and it's going to do this for you. So there's no point in having to do this step-by-step hand, setting up the cluster. That's not what we're here for. We're more interested in collecting the Fluentbit stuff and playing with that. This is all based on Podman. If you don't like Podman and prefer Docker, be my guest, but then you're going to have to go in here and look at what I'm doing and just change the Docker commands, or do what I did on my machine. I changed the Docker into a Podman alias, and it's all the same thing. So it does a bunch of background checks that you have the right kind of container tooling. The Kubernetes tooling I'm using is kind, I don't know what you call it. That your Helm works, it checks all that stuff. And anything that breaks here, because I don't want to have you have a bad experience, I do a lot of effort of checking this stuff for you, telling you what you don't have or what's not right, where to go get it, where to upgrade it, whatever the deal. And he does some checks and waits for that to happen to make sure it's all going down properly. If it fails out, it'll tell you why and what you got to go check. And then we deploy our Fluentbit container, Helm chart, and it tells you all this great information, the stuff you can go do. And for the people that love this stuff, here's your K9S stuff. And basically, you have a whole bunch of kube stuff, and in a default workspace, wrap it all you want, but it's just, all you're seeing here is at the end of the most active stuff was what I just did. But what I want to do is actually get out of this, and let's go over here. And one of the things that I also added to this workshop is a bunch of aliases for you, so we don't have to type all this stuff all the time, because kubeconfig has to be used to find the cluster and all this kind of stuff. So these things I've already applied to my thing. So we can do it's called CKCTL get pods. Hard to type when I'm up like this. Namespace logging. There you see your Fluentbit cluster, and then here somewhere. There we go. Now let's go look at the logs of this thing, and it's going to be pretty nasty because it's collecting everything, right? If we look at some of this stuff, it's got some, you know, I'm looking for my workload. I'm looking for that really concise message that we just saw. I'm looking for to show you this first. Hold on. I need to be shorter. I'm hitting too many wrong keys. Support. I'm a 10-finger typer, not a 1-finger typer. So here's what we actually are doing right now. See that? It's big enough? There we go. So what you're seeing is a Helm chart here. If you look from the point where it says YAML, that's what's inside the YAML file you normally would use with FluentBit. If you're running it from the command line using the source build that I provide, you just do Fluent. He's going to show me. And then from the head, so taking everything in every single file I find, and then it's in the container logs. And then we're doing a multi-line parser to make sense of some of the silly stuff that you get out of there if you just take the raw version. It's really messy. So it turns them into one individual line using these two parsers. And then we have standard out, match everything. That means just dump it to my console. So that's what you just saw go by, yeah? But to make it more interesting, we're going to make our own file, and we're going to start changing some stuff around here. So the first thing we're going to do is we're going to filter down to our generator log. So that's the name of my workload, logs generator, right? And I'm also going to take the formatting of the output, and I'm going to make the JSON lines a little bit cleaner than using the raw date formats. And I'm using the Java timestamp, so that's going to make it a little bit nicer. And then I'm using that big, huge, long command when I've shortened it with that alias I showed you. We're going to redeploy the Helm chart, which means we get a new, we got to check our pods again. We get a new name. And then we can look at the logs here of the new container. B4. And it's already looking a hell of a lot cleaner, isn't it? And if you look at the volume of the stuff that came out, it's a little hard to see here, but now we're basically down to just messages that look an awful lot like what I showed you. A message, a success, and a failure. So we're getting closer to what we're interested in as we're being a developer and debugging on our container. We're focused everything down to just that one application that we want to look at. So the next thing, we want to start using some of the strengths that we have inside of filtering inside of FluentBit. So we're going to use one Fluent filter plugin called grep. Everybody knows grep, right? Just grab something, right? Based on what? So the first thing we would want to be interested in, I think, as a developer would be, I want the error messages. I really don't care about the success messages and the info messages and all that kind of garbage. That's for other people or other reasons that I provide that. But I'm looking right now, what's broken and why isn't it working? Somebody that's interested in this. Done, easy to do as a developer.
Hi everyone, welcome back. We would be starting with our next session, and we'll have Dan and Pedro talk about uh, VM class secure and using Hyperlight Nanvix. So over to you guys.
All right, welcome everyone to our talk. We have VM class secure, millisecond fast, cloud native apps with Hyperlight Nanvix. A quick intro about who we are. I'm Danilo, or Dan.
Pedro. I'm a research software engineer at Microsoft Research. I have a PhD in operating systems and the creator of Nanvix. Yeah, I am happy for having you here and listening for us. Yeah.
Cool. So this is our agenda for today. Main idea is that we'll present you with a problem, the serverless trilemma. We'll then present you with our proposed solution, Hyperlight Nanvix. Then we'll go into a deep dive into security, performance, and compatibility. With the demo gods allowing, we'll have a live demo, and then finish off with some getting involved links and whatnot. Okay, so this is the problem that we have today, serverless trilemma. Oftentimes, with a lot of state-of-the-art solutions that we have today in serverless, you have to pick one of these. Isolation, so C groups, namespaces, right? And just between, I think, 2022 and 2024, there were 7 container breakout vulnerabilities reported. So they're not suited for multi-tenant isolation or something like that, because it's very easy to break out of them. Then we have VMs. They're on the other side of the spectrum. They have strong isolation. They're very secure, and they're compatible. You know, usually people associate VM with
And well, our answer for that is for sure introduce an OS, right? We just said, well, we should take out the OS. Now we are reintroducing it, right? But the idea here is that Nanvix is a completely from scratch OS that we are designing inside Microsoft, and it's an OS specifically tailored for cloud native applications. So basically, Nanvix is a microkernel OS written in Rust. Here's the source code. You should also go check it out. But what's interesting is that we completely co-designed the OS with Hyperlight, which has this very, very lean virtual machine model, right? And the idea here is that we are doing this tightly integration so that we can deliver minimal overheads and the maximum performance. And it's completely designed for the cloud, because cloud workloads are mostly very ephemeral. They run for a very short amounts of periods, and we are just tailoring all the OS services for that. And Nanvix does bring all this compatibility to the table. That is over 150 system calls, and it supports POSIX, JavaScript, WebAssembly, and so on. So basically, Nanvix is kind of an OS, a very lightweight OS that you can run with Hyperlight and bring more interesting applications to this scenario. And here's the logo for Nanvix. It's a dog, but it's mostly here to give you more time to go and check the QR code here for the project. Okay, so how we enable this compatibility, but still having this huge performance and density that Hyperlight can give us, right? So from the architectural perspective, Hyperlight, here you have your Hyperlight VM application deployed on top of your favorite hypervisor, probably Hyper-V, right? And what you have is on host side, you have this host process that offers you this Hyperlight host API that the application can leverage and do more interesting stuff, right? For instance, expose like specific applications that let you access an external resource. But then you can think about, okay, how we want to introduce an OS for that, right? I think that the immediate idea would be, okay, below my application, I put my OS that runs on Hyperlight, right? And what does that mean, right? So imagine that you have an application that is written in Python, right? So it means that you first need to support a language runtime that it's a Python runtime. And believe me, you don't want to go there and write your own CPython distribution by yourself. That's another like job for maybe 20 engineers to do, right? But then if you want to bring CPython or your Dino runtime to the play, you somehow need to support POSIX, because that's how life works, right? Okay, so if you are exposing POSIX to your application, then how you do that, right? Then Nuvix kernel can do a bunch of like stuff, so it can provide you kind of like thread management, memory management, all locally inside of your Hyperlight virtual machine. And with that, you can do way more that you could do with Hyperlight Vanilla. But still, maybe you want access to external resources, such as, I don't know, a file system, an Azure Blob Storage, or something like that. And, well, basically what we do, we kind of leverage this like host process that has this Hyperlight host API to actually have a module there that is taking all the system calls that you have, the I/O system calls, do some like filtering and routing from them. And basically the idea is that in your Hyperlight VM, you are offloading all those system calls to your host process, right? So by doing so, we can expand basically the capabilities of Hyperlight to all those 150 system calls. But then you can imagine, wait for a moment, right? Now I'm basically offloading some I/O system calls to your host OS, which can impose a threat, right? And that breaks the trilemma. Well, actually, this is the simplest like deployment model, and this is just like for educational purposes, right? So the idea here is more to go into more other deployment flavors that we can have with such a flexible architecture that really can get you all the security benefits, still maintaining the performance and the density. So the very first one, let's explore it. So imagine that you have there your Hyperlight VM. You are deploying that in your hypervisor. You have an host OS that somehow has this Hyperlight VMM process that is managing the VMM. But instead of having that system component that is handling all the system call offloading, instead of having that in the same process that you would have in the previous, as I showed in the previous slide, you basically deploy that as a sibling process running in your host OS. Well, if, for instance, you can consider that other process as part of your trust compute based, and you can even imagine that in most of cloud native deployment scenarios, we do kind of that when we are doing like TCP proxying or any kind of proxying to access external resources. You can do one step further and kind of jail all these two processes running on your host OS in a container group, apply syscom filtering and so on to really restrict the access to the underlying host OS resources. Well, this is the multi-process architecture. It has two processes running on the host. One is the Hyperlight VMM process, and the other one is the system process. The thing is here is that the Hyperlight VMM is managing the Hyperlight VM, whereas the system process is handling all the I/O. You still are sharing the underlying host OS, but now you reduce the blast radius, because if the application is buggy, it's just like bringing down the VMM process side of things. And you can still like apply some caching mechanisms in the system process so you can have a very fast startup. But yeah, we are still sharing the host OS kernel. And well, in Microsoft, we are very careful about that. So what we do is like having a very more elaborated deployment. So in this very elaborated deployment, you still have your Hyperlight VM running on top of like your hypervisor. You have the VMM process, but then we introduce another VM. And that another VM is basically hosting that system process. Right now, what we actually have is what we are calling the disaggregated architecture. Because then you have like just 2 processes running on the host, but those 2 processes are basically managing the VMMs, right? And actually, all the code is hypervisor isolated. So the host OS is not shared at all, and you can then apply snapshotting on your system VM and enjoy all the benefits of that technique. Notice here that the system VM is now, the state that belongs to the application is completely decoupled from the state that is generic for whatever workload that you want to run. But, well, maybe you are not trusting me that can save you time and provide you like good code starts, so let's dive into that. Right now, we will check some performance benchmarks that we have for an HTTP server, Echo server application. And let's first understand what happens when you don't know your workload. So you don't know your workload, meaning that you cannot leverage snapshotting at all, for instance, in Firecracker, right? Because you don't know workload, how you will snapshot something that you don't even receive through the network, right? And by doing so, and here we are comparing with a bunch of other like solutions out there that are state of the practice, right? So when we do a comparison with Firecracker, and notice that this is a log scale graph. So we are boosting like the code start latency over Firecracker by 10x, just because I can snapshot my system VM and restore my VM, my system VM from that snapshot. And for the very lightweight hyperlight VMs, I can spin them up on demand. Okay, let's move to the situation where we can leverage Firecracker snapshot, right? Sure, when we do that, what we can do is just, we keep the system VM alive, because basically we can have the system VM running for a given tenant, and that's it. We just pay the cost. Actually, we do that for TCP proxying anyways, right? So when we do that, we are not even paying the cost for restoring the system VM snapshot, and we are just like spinning up hyperlight VMs that are more capable. And again, in that scenario, we can provide a 10x improvement over Firecracker. And interesting enough, if you compare like hyperlight Navics with like vanilla hyperlight, or even process, say that you are spinning like a process in Linux, right? We are very close to that and giving you this like virtualization isolation for your application. So basically, hyperlight Navics does offer these like additional benefits, right? Now, let's take a look on the memory efficiency side of things, right? So memory efficiency and how many of these VMs you can pack is really important from the cloud provider's perspective. So still, when we compare a bunch of like solutions, we put like hyperlight and process as the reference as well. But you can see that there is a 10x improvement over the number of VMs that you can pack in a given like gigabyte of memory. So in 1 gigabyte of memory, we can provide almost like over 200 hyperlight Navics VMs that enables you to deploy more interesting things.
Yeah, so if you're looking at all this and you're thinking, wow, that's so cool, where can I use it? These are a couple of applications that we thought of highlighting. The first one, from my right, your left, is next generation function as a service. The new paradigm here is because these VMs spin up very, very fast, you don't necessarily have to keep a warm pool of resources. You can then just, end that VM and then bring another one back up, and it's just fast like that. The other side is Edge and IoT. In Edge, we usually run with devices that are very, very constrained, and because we spin up so fast and because our memory overhead is so low, we can pack these into Edge and IoT devices very, very easily. And the third one is embedded secure execution. Say you have an application, you want to run some third-party untrusted code, you can use hyperlight Navics as a library to run that code in your code base. So now we'll go for the live demo section of this talk. It's a pretty long demo because we want to display a couple of things. The first thing that we want to display is running various types of workloads. And for this demo specifically, we prepared C example, C++, JavaScript, and Python. And then we'll move on to displaying a demo that has access to the host file system. So there's some file system operations to show how you can then restrict that with Navix's mechanism of syscall interposition or interception. And then we'll put that all together with a cool demo showing how we can run AI-generated code inside of Hyperlight Navix. Okay, so let me bring up my terminal. Okay, try to make this very big, so hopefully it's seeable all the way in the back. This is the Hyperlight Navix repo. We have QR codes for that at the end, so you'll get to access it soon. But essentially what we have in this repo is a couple of things. One is we have the library for Hyperlight Navix that you can embed into your application. And two, we also have a binary, Hyperlight Navix, that you can run to run these from the CLI. Then we have a couple of guest examples. We have JavaScript, a file one, C, C++, and Python. And then the full-fledged example, and this is called interception. So let's walk through it. Thanks, Peter. I don't know if people can still, oh, thanks, appreciate that. All right, so what I'll show you here first. First thing that you'll want to do if you are in the Hyperlight Navix repo is that you'll want, or using the CLI, is you'll want to set up Navix's registry. So that is what downloads all the binaries that we have precompiled for Navix to run some of your workloads, like Python or Python to run Python workloads, Python 3, and QuickJS, which is a QuickJS engine to run your JavaScript workloads, together with the kernel and other binaries like that. So I'll do cargo run. If you're with the CLI, you would just run Hyperlight Navix, and I'll pass in the CLI argument to set up registry. I already have it set up on my machine, so this step is very, very fast. Doesn't really have the time to download anything over the network, but you see it's already cached over here. The next step that it recommends you to do if you want to run applications like C, C++, maybe Rust, is to pull the Navix toolchain. This is just a Docker image that contains Navix's GCC, G++, Clang, Cargo, and so forth. I'll do that too. I also have this already because if I didn't, that would be the end of the talk because it is a 15 gigabyte image, so it's pretty big, and that will take a while, I think, over this network. But luckily, I've prepared. And then with that, it gives you how to compile the examples that you have just in your local machine with that Docker image. So to start, we have this hello C example. It's very simple. It just has a main function, does some prints, some arithmetic, a function loop, and it returns. So I'll compile that, copying this command. And so you'll see here what we're doing is, if I can highlight the specific bit, is that we're calling GCC and passing in our hello C that you're seeing, compiling into this hello C. I already have it precompiled, so you won't see it show
Yep. Hi, everyone. Welcome to the last session for this room. After this, we'll be going there. So we have Sayam and Ritik here who would be talking about scheduling in AI era. So I'll just hand it over to them.
Thank you, Atul. So today we are going to talk about scheduling and how things are working in the GPU ecosystem with all those new things. So a bit about introduction about me. So I'm Ritik. You can follow me at Ritik here. And I'm a platform advocate at vCluster and a CNCF ambassador.
Hey everyone, my name is Sayam and I'm the head of DevRel at vCluster, and you can connect with me.
So today, as we see, a lot of things are hype, and there is a lot of hype around AI and the use cases. With every passing day, we see a lot of posts, a lot of interaction when new use cases are coming in, but all of them are not necessary and just fast storage, fast networking like InfiniBand, and then GPUs. Continuous delivery. So you need to version all those things, and there are projects like Uflow and all, which helps you with that. And then the goal is to have training and inference streamlined. So you can have a AI infra, not just for the company, but for individual teams and individual developers, so that they have a better user experience to create and pursue their requirements.
Okay, let's wake up. So how many of you have written AI application? Basic one, anything, a RAG application or, okay, quite a few. And how many of you have used this for your AI application? This means Kubernetes over here. Okay, cool. And anybody used Kubernetes for any of the few things like develop, training, deploy, serving, monitor? Anyone, that is fine. So basically, what serves as a whole teams, but for your CPU level applications and also for your AI applications. And that's why it is important to understand a few things over here. One, AI applications are rising. You have all these software PCs, fancy technologies, MCP, all that stuff. But in the end, you need GPUs, and people are building those AI farms. People are building those server farms, and there is a lot of innovation happening at the data center level, like reusing the GPU heat to heat up the swimming pool. One of the companies called Deep Green has been doing that, and other set of innovations that is happening. Other things which are happening in the Kubernetes ecosystem is that within Kubernetes also, since it was we'll talk about one of the schedulers in a bit more detail called Kai Scheduler, which was open sourced at, I think, last KubeCon in EU.